video for Unit 1. It is Lesson 1.4, the chapter reference, page 25 in the textbook. One learning target goal, so it should be, should be just a goal, would be to be able to write an equation in terms of the other variable. This is a good example. Celsius is equal to the difference between Fahrenheit and 32 times 5/9. So this is, Celsius is written in terms of Fahrenheit. And then you'll need to be able to write Fahrenheit in terms of Celsius. And we'll go over one of those. There is one vocabulary word written down, so you write this as well, literal equation. It's an equation, so it has an equal sign. I have two examples here that has two or more variables. 3 variables, 2 variables. Jumping right to the first equation is to solve negative 2x minus 3y equals 6 for y. So you need to solve for y. It will be in terms of x though. Our goal is to get the y by itself. Not very calibrated here, but I'll work with it. We would like to remove that term. So remember, when you want to remove an entire term, you add or subtract. You should write that down as well. I am going to add 2x to both sides of the equal sign. Minus 2x plus 2x is 0. Minus 3y, which would be negative 3y, equals 6 plus 2x. Notice I did not put the 6 with the 2x because they are unlike terms. My second step then to get y by itself is to remove the coefficient, negative 3y. So if you want to just remove part of a term, or again, remove part of a term, which is called the coefficient, you multiply or divide. Write that down. It will come in handy. I'm going to divide by negative 3y because this is times. Do not add 3y. Since I divided this term by negative 3, I'm going to do the same thing to each of the terms on the other side. If you saw that I hesitated, it's because you could do them both together, like this, but in the future it's going to be handy to do them separately. Negative 3 divided by negative 3 is 1, or just y. It would be 1y, or y equals, this reduces or simplifies to negative 2/3, and you're going to just leave this. I don't want you to write it as a decimal. You could put negative 2/3 x like that, or the x could be in the numerator. Second equation is to solve for the height. If this looks familiar, that's good. This is from last year. It is to find the surface area of a cylinder. A good old cylinder. Whoops. And again, it's not calibrated. So the cylinder would be to make it or wrap it. So it's the outside. Okay, we want to solve for h. So I want to get h by itself. Notice I'm going to split my equation into 2 equal parts. They are equal. I'm going to first remove this whole term. So remember, to remove a whole term, you add or subtract. So I'm going to subtract 2 pi r squared from both sides. hopefully you're with me. That goes to 0. You're left with 2 pi r h equals the surface area minus 2 pi r squared. Last step is to just remove the 2 pi r because we're looking for just the h. So basically this is the coefficient, the 2 pi, and then the r. So if we remove part of h, part of the term that's attached to h, we multiply or divide. And I am dividing because this is all multiplication. 2, help me out, pi r. All right. So we would have h equals, if you're going to leave it like that, that's fine. Or notice the last problem, I did do it separately also. And I am going to list it separately. This could be the answer, which is fine. You could write that. Or if you want to write them separately, 2 pi r. And either one is fine. Note, if you, this is okay. This would nothing cancels here in this fraction but 2 pi over 2 pi. And one of the r's would cancel with one of these. If you caught that, I'm going to write the final answer over here. S divided by 2 pi r minus r equals h. I just took it one step further. If you want to write this, that's fine too. And this is the equation I started with, going from Celsius to Fahrenheit and vice versa. So we're going to use this in our next example. So you can write it down in the next example. So here we go. This is if you were given Fahrenheit, and we work with Fahrenheit in the United States. If it was 80 degrees, I could put 80 in for F, and I'd find out what the Celsius temperature is. So what I want to do is solve this for Fahrenheit. So you want to get the F by itself. I don't know if you can see that, but that is a division. The easiest thing to do right away, I know you want to use the distributive property, you can do that, or this is times, this times, and I'm going to multiply it by the reciprocal. And that's the same thing as dividing by 9/5. So over here, I'm going to multiply by the same fraction. 5/9 times 9/5 cancels. Again, with multiplication, this could be next to the 5/9, and you would see that it's 1. Leaving me with F minus 32 equals 9/5 times C. We're almost at the F. So minus 32, I want to remove the whole term. I would add, I thought I turned it to blue, I would add 32. Add 32. Cancels. I'm left with F, which it said to solve for F, is equal to 9/5. You can put the C here or in front, it doesn't matter, plus 32. These two are unlike terms, so you cannot combine them. We're going to use that previous equation to help with this example. The room temperature in math class is 70 degrees. Kind of is. The temperature in Mrs. Valeri's room is 23 degrees Celsius. So we got Fahrenheit and Celsius. Is Mrs. Valeri's room greater or less than the math room? So you have to decide, are you changing 70 degrees to Celsius or Celsius to Fahrenheit? Doesn't matter. So let's go back. It doesn't matter which one you use. Where am I here? I'm trying to go back, but here we go. So we can grab this last one we wrote. So 9/5 C plus 32. Let's bring that back. You have it. 9/5 C plus 32 equals degrees Fahrenheit. So let's put 23, let's substitute 23 degrees in here, and we'll get Fahrenheit, and we'll be able to compare them because they have the same units. We have 9/5 times 23 plus 32 equals Fahrenheit degrees. Again, if you need help with multiplying fractions, put a 1 under there. 9 times 23 divided by 5 times 1. Let's pull up a calculator. Please feel free to do the same. 9 times 23 divided by 5. Whoops. Equals. And then I'm going to write that down. 41.4 plus 32 is Fahrenheit. I still have it on my calculator, so I'm going to add to it 32. And I get 73.4 degrees Fahrenheit. Is her room greater or less than? It is greater or warmer than the 40 degrees. Your turn. Solve each equation for y, meaning 1 and 2. And then for number 3, solve the equation for height. And the last one, please make sure you are using either equation. The Celsius equals written in terms of Fahrenheit, or the Fahrenheit written in terms of Celsius to answer number 4. And I will check those the next day. Hopefully that wasn't too long.